All right, folks, today we're going to talk about molarity, and we are doing worksheet number 4. All right. Definition of molarity. Remember that molarity we abbreviate as the letter M, and it's moles of solute, the thing being dissolved, divided by liters of solution. Okay, so this is the total liters of solution. All right, so if you happen to be using something where your solute happens to be a liquid, you're talking about the total liters of solution that you create. Okay, so you have to make sure that you know that. All right, so this really is a lot of plug and chug. It's a lot of potentially doing a little bit of algebra, so nothing exciting. Okay, let's go ahead and do this. Our molarity is equal to moles per liter. All right, and here we're told that we have 3.0 moles of sodium chloride dissolved in 1 liter of solution. So that's real easy. That's 3.0 divided by 1.0. Your answer there clearly is 3.0 molar. All right, again, if we do our molarity is moles per liter, that's going to be 0.50 moles divided by 2.0 liters, right? And 0.5 divided by 2 is equal to 0.25 molar. You should be able to do this math in your head. Right, your molarity is moles per liter, and that's 3.0 divided by 0.25. So that's going to be 12 molar. That is very strong stuff. You don't want to mess with 12 molar sodium hydroxide. Okay. All right. How many liters? Oh, wait a minute. Now, wait a minute. This isn't molarity anymore. Well, yes, it is. Okay. Remember that molarity is equal to moles per liter. So if we don't know liters, well, this simply is an algebra problem. We have to solve for liters. So what are liters? Well, liters are moles over molarity. Okay, so that's pretty easy. Nothing exciting there. So let's see, our moles are 2.0 moles of calcium chloride divided by a 4.0 molar solution, which gives us a 0.5 liters as our answer. Right? So it really isn't as complicated as it might look. Right? Again, we're going to do molarity equals moles per liter. And guys, you'll notice I write this down every time. You say, well, why does he do that? Well, it's because I don't memorize stuff. I know this. All right? But now how do I solve for liters? Every single time I'm going to work it out. And liters are moles divided by molarity. So it's 3.5 divided by 0.5. So that's going to give me 7.0 liters. All right. Again, we're trying to do liters. Molarity is moles per liter. So that means molarity is, liters is moles over molarity, which moles is 1.0, and my molarity is 2.5. Doing that in my head is a little bit trickier. That's 2 over 5, or 4 over 10, which is equal to 0.40, and that's liters. Okay, that's number 4. On to number 5. How many moles of potassium chloride? How many moles? Uh-oh, got another one. Got to figure it out. And you see, guys, I don't memorize that. I say molarity is moles over liter. I'm trying to solve for moles. So that means moles is going to be equal to molarity times liters. Well, my molarity is 3.0. My number of liters are 2.0. So that gives me a total number of moles of 6 moles. All right, actually 6.0. To be precise, we need 2 sig figs there. All right, what's the molarity in which you've got grams? Uh-oh, now we got a problem. We have a little bit more problems. Now, when I do molarity, I see that molarity is moles per liter. I don't see grams there anywhere. Oh, but I do see moles, and I can convert grams into moles. So how much does Kf weigh? Well, if I look at potassium, potassium is 39.1, and fluorine is 19.00. Okay, so that gives me a total of 58.1 grams per mole. All right, so I obviously have to convert 116 grams into moles. So 116 grams of Kf and I have to divide by 58.1 grams of KF in 1 mole of KF. Well, that's pretty easy. I'll notice that's about 2. Right? And when you do it on a calculator, it's not exactly 2, but by the time you end up with sig figs, it's going to end up being 2. So this is 2 moles of KF. Well, now I can do this part where I know my moles and I know my liters, so my molarity is going to be equal to moles, which is 2.0, divided by my liters, which are 2.0. So my answer here is 1.0 molar. All right, how about this one? How many grams of KF? Oh, geez, they're in there. Okay, molarity equals moles per liter. Well, if I'm trying to figure out grams, I have to calculate moles first. Well, moles is equal to my molarity times my liters. My molarity is 3.0. My liters are 2.0. So that gives me 6.0 moles. Well, 6.0 moles of KF, that's moles, 6.0 moles of KF. I have to get rid of moles of KF, and I have to go to grams of KF. Well, last slide I figured out that the grams were 58.1 grams in 1 mole. So I multiplied the 6 by 58.1. I come up with 351, but I have to end up having only 2 sig figs, so that's going to be 350 grams of KF. Seems like a lot of KF to put into 2 liters of water, but that's what you do. All right, number 8, last one. How many grams? Got to figure out moles. So my molarity is equal to moles per liter. So my moles are equal to my molarity times my liters. So my molarity is 0.75 molar, and my liters are, be very careful, you'll notice you don't put in 85, that's 85 milliliters, which is 0.085 liters. So that's 0.085 liters. When I multiply that together, my moles are 0.06325 moles of NH3. But now my problem is I had to figure out grams of NH3. Well, NH3 is 14.007 plus 1.0079 times 3. And that's going to give me 17.031 grams per mole of NH3. Alright, so now I have to convert this number of moles, 0.06325 moles of NH3. I now have to convert that from moles of NH3 to grams of NH3. And my moles, 1 mole weighs 17.031 grams. So when I do the math there, I come up with 1.1 grams of NH3. That's my final answer. That's it, folks. A little bit of algebra. You should be able to do this. If you have questions, please see us in class. We'll be happy to help you. Okay? Take care.